All right, so let's get started. First of all, thanks. It's really cool to have the opportunity to talk with you here. And I really love this community, and I hope you'll tolerate me. I'm going a little bit on a limb, doing something a bit different today, but if I'm among friends, hopefully it's okay. And I'm going to talk about AI agents and live environments and why I'm so excited about them. So the question I'm going to ask is, what if AI, instead of writing code in text files, could manipulate objects directly? What do we get then? And I'll talk a little bit about live systems, what they are, why they didn't really catch on. They became like a marginal, even it's very influential, but a marginal sort of aspect of how we do software. And I'll claim that I think maybe we should now rethink it, given all kind of things that changed, and especially how AI makes them more accessible. So we'll do a little bit of a history lesson. I'll try not to do too much, but I think it's good to put things in context and talk about what's problematic and what I see currently in vibe coding with the traditional or the prevalent software paradigms, and why AI can work really well, offer a better path with live environments. And then I'll demo my own little experiment doing this. So what I'm talking about when I'm talking about live environments is this golden age that started really in the late 50s already, soon after computers became available, with Lisp, and continued with Smalltalk and Self and systems like this. You probably heard with Lisp of some of these kind of systems, and you're probably not using them because they're not the mainstream of how we work today in software, but they've all been very influential and show the way to some things that are very interesting. Lisp started really from research into artificial intelligence. So soon after computer became available, that there already was the dream that we will implement intelligence on computers. And the assumption back then, and not to be exactly the right one, is that we're going to need to represent information in a structured way and make it very malleable. And so the core insight of Lisp is that code and data can be the same thing, which wasn't the case until then and still isn't, right? Mostly we think of code being something separate from the data we operate on. But in Lisp, code and data are the same thing. They have this very minimalist representation. So if you look here, this is data, the list plus 1, 2, 3, and this is code, looks exactly the same. When we evaluate plus 1, 2, 3, we get 6. And this means that code can modify data, data can be code, code can modify code because code is just data. And so you have this great flexibility. And it's also supposed to make the system easier to understand because you're not dealing with these two different realms. And finally, it's the first really live environment. And what I mean here is that you're manipulating objects in the live environment. You're not creating like a program and then compiling it and then running it. But when you have the REPL, the read, eval, print loop, every time you modify something, and you can modify the data, or you can modify a part of the code. And so Lisp is very nice. It's not in that much use today, although there is a little bit, but it's definitely informative. After a while, people start realizing there's something a little bit problematic even with Lisp. And the problem is we say that everything is the same. Code and data, it always looks the same. But then when you actually look at the language and you ask, okay, so what is if here? Is it data? No, it's not data. Is it like a function? Because usually we say, okay, the first thing in the list, like this is a function. No, it's not a function. Turns out it's a special form. This is how it's called. And this is the closest thing Lisp has to programming language syntax. But it's very confusing, right? Because if I'm reading it, I don't really understand. It's not intuitively that if isn't part of this paradigm where everything looks the same. It's part of the system. It's something that will be read and then compiled or interpreted. And so we only partially achieved the goal. And from this realization, really, this was the firing shot of what eventually became Smalltalk. Well, Smalltalk tried to create a system that is really intuitive. And the insight there is that you can build a system where everything is objects that are sending messages to each other. And if you just understand this, that there are objects and that objects can send messages to each other, that's all you need to know. And so everything is an object, numbers, booleans, blocks of code, they're all objects. Everything that happens in the program happens by sending messages between the different objects. It's image-based development, which means that we have everything. The whole world is in memory. It's alive. There's no difference between code, between data. There's no difference between writing step and compilation step and running step. It's just a running system that we can directly modify. And it is indeed very intuitive. And you don't really need to know anything. So if you look at this example here, again, how if is implemented. So in Smalltalk, if, we're just saying, okay, when we send the message larger than to the object A and we tell it the parameter is B, we're just telling it to tell us if you're bigger than B. And if it is, it evaluates to true. And if not, it evaluates to false. And so we have now a Boolean. And when we send the Boolean the message, if true, with a block is like a closure, a lambda, a piece of code that can be run. And if it is true, it says, okay, I should run this block. And if it isn't, we can send it the message of false, and it will run this block. So you have here, you see this very simple construct is implemented only using this paradigm of sending messages between objects. Very nice. And that's Smalltalk systems. I don't know if anyone here had the chance to interact with one. They're really quite a nice thing to work with. But Smalltalk still had a problem that upset some people. And they said, okay, so Smalltalk has classes, right? And we all know classes. This has now became, thanks to Smalltalk, the most common way to do object-oriented programming. But classes, what are they? They're not objects that do anything. They're just like this collection of objects with shared behavior. And so it's, again, there's something very impure, very annoying in the system. And the question that was asked, can we have a language without classes? And so Self grew in the mid-80s already as a variant of something very similar to Smalltalk, but without classes. What only relationships you have between different kinds of objects is of prototype. So if you want an object that is the same as another object, you can say, let's clone object A, we get object B, and now we can modify it a little bit. And if you've worked with JavaScript for long enough, and it's early days before we got TypeScript and classes and all of that, you'll know that JavaScript shares this model of prototypes, and which I guess adopted from Self is actually one of the most popular languages that has this model, but it is very uncommon. Even in JavaScript, it's not being used very much. But it's very nice because if you think about it, you don't have anything now anymore that is about the language, the environment. It is really just objects. Self also grew a system called Morphic. The question that was asked is, okay, how do we make it really easy for people to interact with this system, to understand what it is they're working with? And the thought was, we can have a graphical environment where every object has a direct representation as something graphical on the screen. And it's the same thing. It's almost like you can reach in and touch it because it's an object there that has a visual representation. It's a circle or a box or a button or whatever. And you can, and here you have a screenshot from the original Morphic. You can go and modify it as it is. And this really created this visual programming paradigm. Or if you've seen things like, I don't know, Visual Basic or any of these systems, they were influenced by this. And finally, Self had another innovation that became very influential and important. The problem with systems like Self was that it was very hard to implement them efficiently because they're completely dynamic and anything might change. You don't have the opportunity to compile the program ahead of time. And compiling the program ahead of time is the main way we have to make programs more efficient and not just interpreted. Trying to build this into a system that is workable, that is efficient, that could work on native hardware and a reasonable speed. And the developers of Self came with a brilliant insight, which is that we don't need to compile everything ahead of time because some things we don't do very often. Maybe we don't even do at all, right? If we have dead code, there's no reason to compile it. If we have code we run once or twice, there's no reason to compile it. Interpreting it would be very fun. If you have code that you run 10,000 times, you better compile it because otherwise you'll incur this cost again and again. And so they came up with the idea of the just-in-time compiler. Compile it when you realize that this is something you're doing a lot and it's worth investing the resources in compiling it. And this project became a hotspot. It is incredibly influential to this day, and in some way also the downfall of Self, because in the mid-90s, the Self project itself as an experiment was shut down. The team working on it eventually got acquired by Sun Microsystems, and Hotspot became the Java just-in-time compiler that then influenced the NetCLR, the V8 runtime for JavaScript, and today all dynamic languages have some form of just-in-time compiler. But Self was no longer. It lives on in various forms. Fake was ported back to Smalltalk in a version called Squeak, which is very nice. It's a Smalltalk system for experimentation and education, very playful. Squeak was then in the noughties sparked into Faro, which is today, I believe, the sort of the most current Smalltalk system. It has an active community. It's a very nice system. You can download it and play with it. It suffers from the same limitation, which is it lives in its own image, kind of disconnected a little bit from the rest of the world, but working very well. And Morphic has also been ported to JavaScript by James Munich for a project called Snap, which is a visual programming environment. And this will become important soon because I'll show you how I'm using it. And so the concepts live on, but and as you can see, these languages and these environments became very influential. They informed a lot of what we do today, but they're not what we do today. Why? The best explanation is the one of Richard Gabriel from the early 90s. Richard Gabriel worked on Lisp systems and realized that it is a losing battle, that Unix and C and all Perl, all these languages that work in text files, they're winning. And he tried to explain it. He's a poet. He wrote it beautifully. You should go and read it. It's entertaining and also informative and better than I can describe it. But maybe just a few things to think about. The world of technology in the 70s, 80s, early 90s is very different from today in terms of the constraints that we faced. Memory, for example, you need a lot of memory for a live system that keeps everything in memory. In the 80s, it was incredibly expensive and scarce. Today, memory is abundant, it is very cheap. You can have many gigabytes of memory and it costs you next to nothing. Performance was a real issue. You really needed to squeeze every little bit of performance from the hardware you get. But today we have these amazing CPUs. In fact, no one cares about CPUs anymore, right? Because everyone just cares about GPUs and running these very complicated calculations you have for machine learning. CPUs are cheap and incredibly fast. And also we learned as an industry, we got to a very good understanding of how to build performance systems in a way that really developed after this period. And the same with distribution. So distributing a memory image of a few hundred megabytes was really difficult in the 80s and 90s. Today, I don't know, I have a 10 gigabit internet connection here from my modest apartment. I don't think getting a memory image is going to be a problem for anyone. So things have changed. Was maybe used to be better. I don't know if it still is. So coming to today, AI happened, and especially the last year, AI got good at coding, which is amazing. I'm living this transformation, and it's super exciting. And there are different forms of working with AI for coding, from very controlled workflows people call AI-assisted software development, where proficient developers use AI to augment their work, all the way to vibe coding, which is the buzzword of the last year. And I'm talking here about vibe coding as a subset of AI augmented software development or a powered software development, where people don't pay much attention to the code, either because they're non-developers, they don't actually know how to read and write code, but they're still able to use these tools to build stuff, or because they don't care. And I sometimes, even though I'm a very proficient programmer, I now vibe code and I just ask for stuff in natural language. And if it works, I don't care too much about the resulting code. The problem here is this 70% wall, right? Which anyone who's done anything in vibe coding can describe, where you can get some fast results, sometimes very sophisticated results, until you get to the point where things stop working. You don't understand the system, again, either because you're not a programmer and you don't know how to read the code, or even if you are, you didn't pay attention, you don't really understand the code base anymore, and the AI doesn't cope anymore. You don't have an understanding, a mental model of the system you're dealing with. And this is very common. This is really a blocker, I think, today for more people making better use of AI to build software systems. And I think that's where we should go back and look at live systems, live environments, because they offer a lot of promise. If you think of worse is better, the text files with source code compiling and running and multiple components on the command line, what's happening there is we come with our intent, our requirements, our requests in natural language. AI help us convert this into source code and to compile, to run the program. And then at some point there's confusion. If we know how to debug, we debug. If we don't know how to debug, we're just frustrated. But live environments offer the opportunity to come again with a natural language, with our requirements and requests and wishes, and directly manipulate objects. So there's no intermediate step. We just manipulate the object, we can experience it, we can see it, we can check how it works. And so I think that's something we ought to check again now. I'm trying to do something like this. IntelliMorphic is my own tiny little experiment doing this. I'm using Morphic.js, so it's a part of the original Morphic system. But this time, the morphs, the objects, then don't just have visual representation and code. They are AI agents that you can address, talk to in natural language, and they can talk back or talk to each other in natural language. And so message passing, the idea that came from small talk, is now really message passing. It's not message passing with code, it's message passing by actual talking. And I think with a system like this, non-technicians, non-programmers can build and experience the system directly without this mediation of source code and compilation steps and all this stuff that makes things complicated, and can work in systems that continuously evolve and can also continuously learn from direct experience. And trust me, that's a lot of fun. So now we will pray to the gods for a good live demo, because this is always a bit of a challenge, but I will try to show you what I have here and the version 00001 of IntelliMorphic. So this is it. This is Morphic. So it doesn't look so impressive. It looks a bit 80s, right? But it's a nice system where you have objects that they all have a visual representation and I can interact with directly. And these are all AI agents, all objects here. And the only addition I made here is I have this chat interface. This is the commander. So the commander can send messages to any of the morphs, any of the objects, and the morphs can send messages to each other. So let's look at a few examples, maybe something like this. Let's say box 0. So here's that's box 0. And we tell it, say, hereby declare you dark green. And as you can see here now, the commander sent a message to box 0, and box 0 used its agentic AI capabilities to figure out, okay, to fulfill this request, I need to set the color, and now I have a dark green object. That's pretty cool, pretty simple. Again, the important thing here is that I'm not just using AI agent with tools to modify things in the environment, but I actually sent a message to the box and it modified itself. And these objects can send messages to each other. So let's try something a bit more complicated. Let's say that I tell the circle box, which is this thing here, where you are clicked, you should tell frame 0, which is this thing here, to change its color to random color on your choosing. I'm sending this message to the circle box. It got it and decided to do some things. And now when I click it, now the circle box is sending a message to the frame and telling it, change your color. A very simple example, but here are morphs talking to each other and they're using natural language. I'm talking with them using natural language. They talk to each other using natural language. What's something maybe a bit more complex? Let's say frame 0. When I double click here, you should politely ask box 0 to come a bit closer to you. Tell it where you are and suggest that it moves nearby. And so the frame got the message and it decided to do something. What happens when I double click it? It says, hello, box 0, could you please come a bit closer? And the box comes. So now I have this more complex behavior between multiple objects. And I can also talk to the world and get it to do new things for me. So for example, world 0, this is everything, this gray box, this is the world. Should have a large red circle within you. Yeah, it totally did this, but now this circle is hiding everything, so I can tell it circle 1, you are hiding everything. Go to the back, please. Good. So Very simple system. I know these are just a few shapes on the screen, but imagine the power of a system like this with components that can present complete user interfaces, that can take actions, call different things. We're now, instead of preparing some text files and hoping that it will work when the system runs it, we now are interacting with the object directly. We're modifying them. We are asking them. They're replying to us. They're interacting with each other. And we're doing all of that thanks to the AI capabilities we have now. We're doing all of that in natural language. So yeah, that's all I have to show for you today. This is the beginning of what I hope will be a bigger journey. And super curious to hear your questions, ideas, thoughts.
Thank you for your great presentation and demo. The demo was working fine, which is
Amazing. Yes,
an
it's my lucky
achievement
day.
on it. It's an achievement. The question, Eric, you want to ask the question to Eleanor?
So I was not ready to talk about it, but I think it's already in talk. But basically, the correct is saying that Modify is more a runtime approach. Don't have any classifiers, which is more than it's something that you combine everything.
Yes, that's exactly it. So I'll repeat this also in the chat, but we're doing everything in runtime. There is no difference. There's no step where we write the code, step where we compile the code, step where we put it in a Docker container and upload it to the cloud. It's one living system where everything we modify immediately changes. The prototypes help with this because we don't think in terms of stuff like classes that they're a step before, right? We would prepare to have later on an object. And so the cool thing here, and especially I think cool for people who are not as spoiled like us, ruined with the mindset of programmers, is just like the real world where if I take a thing here, it's here. I didn't create a big plan of how there's a class of things that are like pens, and then sometimes I can pick them up. I just went and picked it up. And so it's much more intuitive in this way.
I only have a question now. Is the world in introspection capabilities, that is to say, is the world able to know the rules between the objects in itself?
Exactly. Yes, everything is available for introspection. The objects can look within themselves. The objects can have children. So all these children, they are all these shapes you've seen, they are children of the world object. They can also have objects within them if you build more complex user interface elements, and they can all look, understand, modify. There's no restriction there.
And the messages are objects on their own?
The messages are text. They're just natural language. So they're just like the messages here in the chat. I'm telling you, just like I can tell you, hey, Pierre, pass me the water. If we're here in the same room, these objects can send each other messages, or I can send them messages.
So I will just ask the question of Eric and then Pierre-Yves. So what the talk inspires me is that we could build UIs by making each component responsible of its task and interactively refine their properties, state, etc. during development. For example, in context of React UIs, Vercel AI SDKs, without putting React components, for instance.
Yeah, this is, I think, the central inside of systems like Smalltalk itself already, and I just adapted it here to try and stay true to this concept. It's, of course, when we want to build systems that will be attractive to contemporary users and interact with the world, we might want to switch to the document object model, to React, to these kind of systems. Obviously, the look of this stuff is not that appealing. But the problem there is immediately we start making compromises, right? Even React, if you think, what is the concept of React? It took the document object model, which is quite close to a live system like this, right, with objects you can modify, and said, that's not very efficient, let's have a shadow DOM. And this helps a lot with efficiency. It renders quickly, changes are very responsive. This is wonderful, but we lose a little bit the property, or at least we need to manage it very tightly or for this illusion to remain in place. So it's always a compromise. Even today, when we have very fast systems, full dynamism requires some additional support to implement in a way that would be responsive and efficient, but it's doable. I think what I want to already myself and you today is I don't think it's mission impossible. I think it's mission complicated, hard, but worth doing.
Pierre-Yves.
Yes, a great demo. Will we be able to expand the object capabilities?
What do you mean?
Now you can ask the object to go in the back to change their color. If you imagine something and you want to add more skills or capabilities to the object, will it be possible?
Yeah, so as you can, like even in the demo, I showed a little bit of this when I told it, okay, new behavior. Now when I click you, you should be doing something. And it created a new method as an event handler. But you can do more of that. And all the possibilities currently exist in the Morphic system, which is completely open. Add a new method or a new kind of message you can receive. It's all open. The challenge is making it work well with AI. So there's a bit of a balance. I'm telling you behind the scene as the implementer, enough context for it to understand what to do, a model strong enough to be able to understand these things, but also even like this, it's a bit slow. I'm using here GPT-5 mini with no reasoning. Add to it something more complex, it gets a bit slower. So there's a balancing act here, and not everything that's possible. I'm playing with it a lot now, and it's just a lot of fun, like asking all kind of different things and saying, oh, try to do this, try to do that, and some things work and some things not yet, because they're limitation in the AI where it doesn't interpret it correctly. But I think iteratively this can be improved a lot.
And can you change an object? Can you decide to make an object from a square and say, okay, from now on, you're a circle?
I guess you would need it will be a new object, but you could, yes.
Any other questions?
I do have one.
Yeah.
But thank you, Eleanor, for the history and the demo. That was really amazing. So I'm just wondering what use case you can handle with this kind of technology. Because for me, it looks like maybe I don't want to shrink what you've done. It looks like a kind of awesome low-code editor. This is the view I have right now. So I'm wondering what use case can be handled with this technology.
I have a few things in mind, but I'm also curious to hear more ideas from everyone. One thing I'm thinking, so I'm talking to lots of people who are non-programmers, and they're creative. They have amazing ideas what to build. They're using things like NA10, for example. Now, NA10 is an amazing system, but it's cheating. It is programming. Like sure, you're not programming with writing code, but it's the same paradigm where you have to set everything in place. And if you made a mistake, you'll only find out when you run it. And so I think if people had a system that is a live environment where they interact with it directly, it will be much more inviting to people who are not already spoiled by this programmer mindset so many of us have, and just have an idea and just want to try it out, experience how it works, make some tweaks. And so I think a lot of things like this, where people want to create their own little application, their own little workflow or something like this, would be served well by a system. And this obviously with the richer UI, with more sophisticated capabilities. Other ideas I have, I think a lot of the way we think today about applications, they're very static, calcified thing, right? If I download or I sign up to some web application, it always looks the same. It always behaves the same. And this is necessary because I'm the end user. I'm not supposed to understand how this application works. But a system like this kind of offers the opportunity to give me just the capabilities. And I look here, we initialize it. There are like 3 buttons here and a window here. But you can do it whatever you want because you can't go wrong. You can't have a syntax error or a compilation program. So make of it whatever you want. This is just a starting point. And it's a bit hard for us to imagine because we spent the last 20, 25 years working in this very specific way of applications that are packaged, that are not to be changed anymore after they've been compiled. But after you start playing with it a little bit, you spend a bit of time in a small talk system or even in this little toy, you start realizing there's no reason for that. All of this could be changed if it just was in a form that is accessible to me, that is easy for me to understand, that I can experience immediately.
But it's personalized, something like that. Okay, this is the use case you mentioned right now.
Personalized UI, personalized behavior, anything.
Yeah.
Is like Lego. Instead of getting the toy already assembled, I have the Lego and I can use it like in the brochure, or I can do my own thing out of it.
Okay. Thank you.
Thank you very much, Leonor. It was an awesome presentation. Really appreciate. It was almost like between philosophy, history, and super innovative ideas. Thank you very much. Thank you
Thanks,
very much.
everyone, for
Yeah.
for the opportunity, and it was so much fun for the questions.